Now this is a special kind of question in the sense they are even giving you the context switching time. So what is context switching time is, I told you, so when a process is running, we are going to stop it and then schedule the next process. And in between many things will happen. So when a process is running, in between the scheduler has to come, it has to execute, and then it has to take the other one and then pick it up and then put it there. See, what I mean to say is, when you are in ready queue, there are many processes, right? And now in running, we have to pick one from here and we have to give it to there, right? So whenever any process finishes, then the scheduler has to be invoked, that short-term scheduler, which is going to decide which process has to be chosen next. Once we have taken that, the next process that can be run for scheduling, that can be run, right? Now the entire process, the time is, first you have to call the scheduler and scheduler will call the dispatcher, and in fact these two are processes, they have to execute, and dispatcher will change the context, and finally the process will run. Once a process is over, scheduler will be called and scheduler will call the dispatcher giving you the process, and finally dispatcher will make the process available for running. So for this entire time, for this entire thing to happen, some time is going to be wasted, right? So they are saying that the time wasted by the CPU in order to do that, this entire procedure is 1 unit, right? Generally they don't specify it in any gate questions, but it is better if you are aware of it. They don't ask it, they didn't ask it, but then and one more thing, in all the questions you need not do this, since they have specifically specified that this is the condition, I am doing it. Okay, in all the questions you do the normal way, which I have shown you in all the remaining questions, which I will show you also. Okay, now see this. If you watch the first one, the arrival time of the first one is actually 0, but then before you schedule it, you have to call the scheduler, and then the scheduler has to pick it up and then do the context switching and then run it. So for that, 1 unit of time is always wasted. Therefore before you actually run the process, 1 unit of time is wasted, right? And now then this P1 will be taken and P1 will execute for 3 units of time. So what is 3 units? 1 plus 3 is 4. Got it? And after this P1 executes for this 3 units of time, then the next one gets scheduled, but then there has to be again this entire delay overhead, right? Again that is 1 unit, therefore 5, and after that the next process will be scheduled. The next process is nothing but P2, which will run for 2 units. See, it is first come first served, that is why I am doing this, right? And it will run for 2 units, which means 7, and after that again we have to schedule the next one, therefore overhead involved is 1 unit, therefore 8, and after that P3 will be scheduled, P3, and P3 will run for 1 unit, which means till 9, and again there has to be overhead, so overhead is 1 unit, which means 10, and again next one has to run, so that is P4. So P4 will run for 4 units, therefore it is 14, and again there will be overhead for 1 unit, which means 15, and after that P5 has to run. P5 is going to run for 5 units, so P5 is going to run for 5 units, therefore it is 20, and again there will be a overhead, and after this overhead delta again P6 has to run, and that is where we are going to end it, right? P6 is going to, it is 21, right? And P6 is going to run for 2 units, therefore it is 23, right? And you can stop it there. This is the schedule, right? So the total schedule is, you start at 0 and you have run till 23, therefore the total schedule length is 23, out of which what is useful time and what is the useless time? Useless time is nothing but the time spent for this overhead. So if you look at the overheads, 1, 2, 3, 4, 5, 6, 6 overheads are there, therefore 6 by 23 is the inefficiency, right? If you multiply with 100, you will get in percentage. This is the inefficiency. Then what is efficiency? Efficiency is remaining time, right? So how much is remaining? You can check it. So it is 1 minus 6 by 23 is the efficiency. If this is the inefficiency, it is the efficiency, right? Therefore this is the efficiency of this. So efficiency is actually less. The reason is we are having all these overheads. Got it? So don't do this always, which means unless they give it that there is some overhead between two switches, before scheduling a process there is a overhead. Otherwise, don't do it. Right here they have specifically mentioned that before you schedule a process, there has to be some overhead. That is, you have to call the short-term scheduler will call the dispatcher, and finally you can start it. In case if that such thing is mentioned, then only do like this, and this is completely valid. Okay.